Hello students, today we will learn about differentiation. Suppose y equal to fx is a functions, real valued functions. Suppose for different values of x, we will get different values of y. Here x is called argument and fx is the functional value. If x changes, then fx changes. Suppose when the argument is x, then the functional value y equal to fx. If the argument x receives an increment delta x is the increment of x. It is immaterial to say that delta x may be positive or negative. The increment of x may be positive or negative. If x, that is argument, receives an increment delta x, then fx will change. Then the value of fx will be f of function of x plus delta x. Then this value we denote by y plus delta y. That is y, when x receives an increment delta x, then y receives an increment delta y. Then y plus delta y equal to function of x plus delta x. Now y, what is the value of y? Y equal to fx plus delta y equal to f of x plus delta x. Then delta y equal to f of x plus delta x minus fx. That is when x receives an increment delta x, then the increment of delta y equal to function of x plus delta x minus function of x. Now delta y divided by delta x, that is ratio of increment of y to the increment of x. This equals to f of function of x plus delta x minus fx by delta x. This denotes the ratio of increment of y to the increment of x. And if the increment delta x is very small, nearly very small and nearly equal to 0, that is when delta x tends to 0, delta y tends to 0, then the limiting value, limit delta x tends to 0, we take limit delta x tends to 0 on both sides. Limit delta x tends to 0, this will be f of x plus delta x minus fx by delta x. We say this limit delta y x tends to 0, delta y divided by delta x. This equals to this. Delta y tends to 0. Then this limit may exist or may not exist. If this limit exists and its value is a finite value, then this limit is called the derivative of the function fx with respect to x. Then this is the rate of change of fx with respect to delta x, and it is the instantaneous rate of change because delta x is very small. So derivative actually represent a rate measure, a rate of change of a functional value with respect to its argument. And symbolically we denoted this by ddx of y or f dash x. This equals to limit delta x tends to 0, f of x plus delta x minus fx by delta x. Sometimes we write delta x by the symbol small h. by the symbol small h. Then if we write delta x by h, then f dash x, that is derivative of fx, equal to limit h tends to 0 f of x plus h minus fx divided by h. This is called first principle or definitions of derivative. Now it is obvious that derivative represents limit. So derivative, since limit has two types, left hand limit and right hand limit, so derivative must come left hand derivative and left hand derivative, then it is left hand derivative, left hand differentiation, this equals to left hand derivative of fx equals to limit, then h tends to 0 minus f of x plus h minus f of x divided by this, that is h approaches to 0 but from the left hand side, that is h, the value of h must be less than equals to 0 but it tends to 0. And the right hand derivative of fx, this will be obviously limit h tends to 0 plus f of x plus h minus fx divided by h, that is the value of h always greater than 0 but approaches to 0. If these two derivatives are equal, that is left hand derivative equal to right hand derivative, it is left hand derivative equal to right hand derivative, left hand derivative equals to right hand derivative, then we say the derivative of fx at the point x exists. Okay, so derivative, left hand derivative, right hand derivative, both the derivative must be equal, then we say derivative exists. Now derivative at the point A, at the point A, derivative at some particular point A. Since we know f dash x equals to limit h tends to 0 f of x plus h minus fx by h, then derivative at the point A must be f dash A. Sometimes we denote this ddx of y at x equal to A. This equals to limit h tends to 0 f of a plus h minus f of a. We write a for x, a for x, a plus h minus fa divided by h. This is the derivative at the point A. Now, if we put a plus h equal to x, any variable, then here h tends to 0, h tends to 0, if h approaches to 0, then x approaches to a plus 0, that is a, then x approaches to a. When h approaches to 0, if we put here 0, then x tends to a plus 0, that is x approaches to a, and the value of h from here x minus a. When x approaches to a, then h tends to 0, or h approaches to a 0, then x approaches to a. Then this limit becomes limit h tends to 0 means x tends to a. X tends to a. F of a plus h means x minus f of a divide by h means x minus a. This is also another form of derivative at the point a. F dash a equal to limit x tends to a fx minus fa divided by x minus a. This is also differentiation, same thing but different form. So derivative at the point a, f dash a equal to limit h tends to 0 f of a plus h minus fa divided by h, or f dash a equals to limit x tends to a fx minus fa divided by x minus a. Now geometrical representations. Suppose y equal to fx in rectangular Cartesian coordinate systems. Y equal to, this is x-axis, y-axis, origin. Y equal to fx. This curve is denoted by y equals to fx. Y equals to fx. Y equals to fx is a function defined on some interval. Then, if this point is P, whose coordinate is x and y, x comma P, x comma y, then this equal to x and this equal to y. Coordinate x comma y. Y means fx. Y equal to fx. We can write p x comma fx also. And q is another point, very neighboring point. Q point. Q, coordinate of q. If the value of x receives an increment delta x. This is delta x. Delta x. Then this equals to x plus delta x. Then coordinate of q x plus delta x, comma. Then the value of this is y plus delta y. Y plus delta y. Then we draw a perpendicular from P to this line. Suppose this point is M. Then this value is y, this also y, and this is the increment of y, delta y. Then this is y plus delta y. Obviously this is delta x, this also delta x. We join the second PQ or chord PQ. Suppose the PQ makes an angle theta with the x-axis, that is parallel to x-axis. If we draw this is x-axis, theta, this theta. From this figure, delta y by delta x represent tan theta. Tan theta equals to delta y divided by delta x. What is delta y by delta x? Delta y by delta x represent the slope of the secant PQ. Slope of the secant PQ. Perpendicular by base. Slope. Now, if delta x tends to 0, obviously delta y tends to 0. Because if the delta x tends to 0 means P is fixed point, Q approaches to P. Q approaches to P along the curve. Then suppose Q points comes here. Then this will be delta x. Delta x was initially this will be, then delta y will be this. Then if delta x decreases, tends to 0, then delta y, numerical value of delta y also decreases. That is, if q approaches to where more near to p, then here, then this will be delta x and this will be delta y. Then delta x when decreases, then delta y also decreases. When q comes here, then delta x will be this and delta y this. That is, when delta x tends to 0, delta y tends to 0. Then the limit when delta x tends to 0, delta y divided by delta x. That is, limit delta x tends to 0, delta y means f of x plus delta x minus fx by delta x. This equals to limit. Then what will be this limit? This limit, when if we draw like this line, this line is theta. If q comes here, the secant will change. The secant length of secant will be 0. PQ tends to 0. Ultimately, when q approaches to p, then this secant will be tangent, because we will get ultimately 1 point tangent. When the secant is PQ, then this chord, if we extend meet x-axis to this point and making an angle theta. When Q tends to P or approaches to P, then this secant will change. Also the slope will be changed. That is, angle of inclinations will be changed. Ultimately, when Q approaches to P, then these secants will convert it to or changes to tangents, become tangents. If this tangents makes an angle psi, with the positive directions of x-axis, then this will be, when x approaches to this will be tan psi. Tan psi means limit tan theta. When theta tends to psi or delta x tends to 0. When delta x tends to 0, theta mass tends to psi. When delta x tends to 0, that is when Q approaches to P along the curve, then theta gradually changes. Ultimately, when Q comes to P, then the secant will be tangent, and the tangent makes an angle psi with the positive direction of x-axis, that is theta tends to psi. When delta x tends to 0, delta y tends to 0, theta tends to psi, and the ratio of the increment of y with to the increment of delta x tends to a finite limit. If finite limit, then we say this equals to, this is the differentiations of fx with respect to x. That is, differentiations of fx at any point represent the slope of the tangent at that point. Slope of the tangent, it is dy dx. This limit is denoted by ddx of y. ddx of y. This equals to tan psi. That is, slope represent, that is, derivative represents slope of the tangents. Slope of the tangents. Derivative represents slope of the tangents. This is the geometrical interpretation. So, when we have to find out the equations of a tangent at some point on the curve, then we have to first calculate derivative at that point. If we know the derivative and we know the point, so we can apply y minus y1 equal to m into x minus x1 equation of tangent. For the value of m, we will put the derivative at that point. That is, f dash a dy minus y1 equals to ddx of y at the point x1 y1 into x minus x1. This will represent the equations of tangents. So from with the help of differentiation we can find out the equation of tangents at some point. Now differentiations of some functions. Differentiations of some functions. So differentiations of constant functions, k constant equals to 0. K equal to constant. Differentiation of constant functions is 0. It is very easy to prove that if fx equals to k constant, then x plus h is also equal to k, because fx is constant. For any argument the value of fx is k, then f dash k, derivative at the point k, limit h tends to 0, f of x plus h minus f of x divided by h, this equals to limit h tends to 0, this equals to k minus k by h, this equals to limit h tends to 0, 0 by h equals to 0. That is derivative of any constant function equal to 0. Now differentiation ddx of e power x, this equals to e power x, derivative of e power x equals to e power x. This is also very easy to prove. Let fx equals to e power x, then f of x plus h equal to e power x plus h, then f dash x equals to limit h tends to 0, fx plus h minus fx divided by h equal to limit h tends to 0, e power x plus h minus e power x by h equal to limit h tends to 0, e power x plus h means e power x into e power h minus e power x by h, limit h tends to 0. If you take e power x as common, e power h minus 1 by h. Since the limit depends on h, not on x, so e power x is constant with respect to the limit. Then e power x comes out, limit h tends to 0, e power h minus 1 by h. This equals to 1. The formula of limit, that is e power x into 1 e power x. So derivative of e power x equals to e power x. From the first principle, we can calculate the derivatives of some special functions which is known as the formula. I give them. Number 1, ddx of constant function is 0. Number 2, ddx of e power x equals to e power x. Number 3, ddx of x power n equals to n x power n minus 1. Number 4, ddx of a power x. A is not e, a is any constant. A power x into log of a base e. Number 5, ddx of sin x equal to cos x. Number 6, ddx of cos x equals to minus sin x. Number 7, ddx of tan x equal to sec square x. Number 8, ddx of sec x equal to sec x tan x. Number 9, ddx of cosec x equal to minus cosec x into cot x. Number 10, ddx of cot x equals to minus cosec square x. Number 11, ddx of sum inverse function sin inverse x equals to 1 by root over 1 minus x square. Number 12, ddx of cos inverse x equals to minus 1 by root over 1 minus x square. Number 13, ddx of tan inverse x equals to 1 by 1 plus x square. Number 14, ddx of cot inverse x equals to minus 1 by 1 plus x square. Number 15, ddx of sec inverse x equals to 1 by x root over x square minus 1. ddx of cosec inverse x equals to minus 1 by x root over x square minus 1. Number 17, ddx of log x equals to 1 by x. These are some standard differentiations which must need to memory. Okay. So this is the first principle of derivative and some formulas on derivative. So next day we will calculate the differentiation of different types of functions. Okay, thank you.